this video is what we reviewed before we started our activity on entropy and Gibbs free energy. Both are topics that are covered in chapter 17 of our textbook. So these definitions are from chapter 6 when we first talked about thermochemistry and enthalpy. So some important definitions to remember. Then any chemical reaction, we divide the universe into two parts. Now, the universe is the area of study for the situation. So yeah, maybe it will be our solar system or the galaxy or something like that. But it could be, an ecosystem, or it could be the chemical reaction kind of thing. So the universe is just the area of study. Then the system is the part of the universe which we focus our attention on, and the surroundings include everything else. A lot of times, remember, we as people are in the surroundings. For more information about this, you can refer back to chapter 6, but remember that a reaction is called exothermic when it loses heat or the energy flows out of the system. So the energy is given to the surroundings. So in any exothermic reaction, some of the potential energy stored in the chemical bonds is then converted to thermal energy, which would be random kinetic energy via the heat. And an endothermic reaction is when heat is flowing into the system or it's absorbed from the surroundings. So in any endothermic reaction, the energy that flows into the system as heat is used to increase the potential energy of the system. Okay, so just reviewing endothermic, exothermic systems, surroundings, all of those terms are going to be used in the activity that we do, which is a POGL, and so knowing those is good. Now, also from chapter 6, we learned about the first law of thermodynamics, which thermodynamics is the study of energy and its interconversions. So the law of conservation of energy is also often called the first law of thermodynamics, which states that the energy of the universe is constant. So to go along with this, we had internal energy, which is signified by the letter E, is defined most precisely as the sum of the kinetic and potential energies of all particles in the system, where the kinetic energy, the internal energy, change in internal energy, is equal to Q plus W. Q stands for heat and W stands for work. So we did focus a little on work, but in the past we mainly have focused on heat, and in Chem 1 we focused mainly on heat. So now in chapter 17 we get to the second law of thermodynamics, which states that in any spontaneous process there is always an increase in the entropy of the universe. Well, to paraphrase that, you could also say that the energy of the universe is increasing. Remember, the universe is whatever you are focusing on, whatever is your situation. Okay? Now, we need to define what is spontaneous. What is entropy? Entropy can be viewed as a measure of the molecular randomness or disorder. There's not a really good definition of it, so that's what I found from the textbook. It's the driving force for a spontaneous reaction to increase the entropy of the universe. So increasing the entropy will drive a spontaneous process. Entropy is a thermodynamic function that will describe the number of arrangements, which could be positions and or energy levels, that are available to a system existing in a given state. So entropy is a way to measure. It's something that you don't always necessarily look at where each individual molecule is, but overall what's happening. Okay, so now the word spontaneous is if something will happen without intervention. So it's a spontaneous process if it does not have any outside intervention. Well, what could be outside intervention? That could be a catalyst added or used. Maybe it needs to react at a certain temperature. Maybe it needs to have a higher concentration in order to react. Activation energy might need to be overcome. Anything like that could be outside intervention. So now the activity that we're going to do, the POGL that we're going to do, kind of helps us to start think about things. We've always thought about chemical reactions as just happening, but some of them are more spontaneous than others without outside intervention. it also has to do with the rate of the reaction, how fast something will go. Like, we know that metal rusts, but it doesn't just happen instantaneously. It happens over a slow period of time. So that's what we're going to get into with our activity. Hopefully this is a good base for that. If you need a copy of that activity, let me know.